So here we are going to discuss the inverse of a 2 by 2 matrix, how to calculate the inverse of a 2 by 2 matrix. So it's basically 1 over the determinant times the adjoint. The determinant is the product of the leading minus the product of the non-leading, and the adjoint is such that you swap the positions of the main diagonal, which is the leading diagonal, and you invert the signs of the secondary diagonal, which is the non-leading diagonal. That's how you get the adjoint. So here's the formula. A inverse is equal to 1 over the determinant times the adjoint. Okay, so I can see here the adjoint, you swap the positions of B and A, and you change the signs of B and C. So here we have an example, 2, 3, 1, and 4. So the leading diagonal is 2 and 4, and the non-leading diagonal is 1 and 3. Okay, meaning the main diagonal is 2 and 4, and the secondary diagonal is 1 and 3. So A inverse is equal to 1 over the product of the leading, so that will be 2 times 4, minus the product of the non-leading, which is 1 times 3, times the adjoint. So 4 and 2 have to swap positions. So 4 take the position of 2, 2 take the position of 4, and the 1 and 3 have to change signs. So they were both positive, they will now become both negative. So now we are going to simplify. The A inverse is equal to 1 over 2 4s are 8, minus 1 times 3 is 3, times the adjoint. And A inverse is equal to 1 over 5, because 8 minus 3 is 5, times the adjoint, which is 4 minus 3, 2 minus 1. You can leave the 1 over the determinant outside, so that 1/5 can remain outside of the bracket there, outside of the matrix. 4 minus 3 minus 1, 2, so that the answer can remain more presentable, instead of having 4 over 5 minus 3 over 5, 2 over 5 minus 1 over 5, which can look a little bit, overwhelming. So therefore, now we can leave the fraction as a scalar multiplication outside of the matrix. So here you have it, the steps to calculate the inverse of a 2 by 2 matrix.